The fifth part of the lecture number 4 is about wind. This figure shows the instrument to measure the wind, and this graph shows the relationship between time and the wind direction and wind speed. You can see that the fluctuation of the wind speed, and even in the same day, different hour, the direction of the wind can be changed. Okay. To explain the velocity profile of the wind, we use the logarithmic equation. To this equation to explain the wind speed with the elevation. Because u is a function of the elevation of the wind, and u star is the shear velocity, and k is just a constant, common constant, and z naught is the roughness height. And u star can be estimated from the boundary shear stress and divided by density. For the roughness height, z naught, it depends on the surface. Okay, for example, this is for ice. Or the smooth mud. It is for water. This for the glass. Different heights. And this for the bush. For the tree. Okay. This shows the change of wind speed with the wind velocity in terms of meter per second with the elevation z. Okay. And so that is the equation for the logarithmic profile. Another form of the logarithmic profile we can write in terms of the relative velocity between different elevation z and z1, or we can write in terms of the power function. This example shows if the given wind speed 5 meters at 2 meters above the ground, and the roughness height is 0.8 centimeter, compute the friction velocity and b wind speed at the 0.5 meter. So first we have to estimate what is the shear velocity. So based on the logarithmic profile, we can estimate the shear velocity equal to 36.2, and use the same equation to estimate the u at 0.5 meter is about 3.64. So in this case we can draw the profile of the wind speed like this. Okay, at about 2 meters. We have got given the wind speed is 5 meters, but at 0.5 speed be 3.74. Okay. The next figure shows the change of wind, its wind speed. Okay, wind speed with the time of the day. So you can see that about 12 o'clock during the midday, the lunchtime, the wind speed is maximum wind speed occur on this time, and in different location from different light. In this figure show the change of wind speed with the time. If different day by day, so its wind speed can be changed in from one day to the other day. Next topic is about weather station. Okay. Weather station, we can now is like compact weather station. We can measure everything in this station. So this one we can measure. Let's start from the velocity. We use this for wind velocity. Sorry. Okay. So we can, for measure wind velocity and wind direction, we use this instrument to measure the wind velocity and wind direction. And for sun solar radiation, so we can use like the silicon cell or the thermopile pyranometer. Okay, so this is like this part is the solar radiation, and for the next is we can measure the humidity. Okay, we can use this instrument to measure the humidity and temperature. Okay, this part. Okay, so this is the base, and the other thing is for the rain. I think there is no instrument for the rain case on this weather station. Okay, and to measure the moisture, measure soil moisture, they can use this instrument to devise from the ground. We can measure the soil moisture. And for the pressure, we can use this. We can use this to measure the pressure in this instrument as well. The other way to measure the rainfall, we can use we call the radio detection and ranging, or we can, in a short, we call it a radar. In Thai we call radar. To the system of this radar is send the signal the pulse wave to the object, and the diffraction from and the and it's bring back the pulse from the object, from the target, and receiver receive the signal from and can analyze and understand what is the location of the target and what is the size of the target. For the rainfall, it look like this. They send the signal to the cloud and get reflection from the cloud back to the radar. Or this way, they just send the radio wave, okay, to the cloud, and because of the reflection, the frequency of the wave is changed. So based on the change of frequency, we can estimate the size of the cloud, and we can estimate the rainfall that come from the cloud and the movement of the cloud. Okay, the other method that we can use to measure the weather, or can use to measure the rainfall, we call the meteorological satellite. Okay. In this case, from the sun, the radiation from the sun reflect to the reflect to the cloud and send diffraction from the cloud. The satellite can record the reflection signal from the cloud and send the signal to the antenna receiver and do analysis. So this one we call the remote sensing process. Use the satellite to identify the size of the cloud and the movement of the cloud. Okay. One of satellite we call the TIROS. This is what TIROS, the satellite to measure to measure the weather station, to measure the weather data from the sky. Different kind of the instrument, we can use passive microwave and active microwave or another instrument. Okay.